In this question, use a ruler and a pair of compasses. Part A, line PQ drawn below is part of a triangle PQR. Construct the triangle PQR in which angle QPR is equals to 30 degrees and line PR is equals to 8 centimeters. So we'll begin with that. So line PQ is there. We need to construct triangle PQR, and the angle at P should be 30 degrees. So how do we construct? We start with that, the angle at P. That is angle QPR is equals to 30. So that means the angle at P is the one that it should be 30 degrees. So to construct 30 degrees, you stand at P. First, you begin by constructing 60 and then you bisect it. So you stand at P with any suitable radius, mark an arc with the same radius without changing it. You stand at this arc and then you cut that arc. So that is 60 degrees. How do you get 60? If you join the point of intersection of this arc, so from this point, so you have this point here, from point P, if you join to this point of intersection, you draw a line, a straight line, you get 60. I don't need to draw that because I need 30. So I'll bisect that one directly the way it is. This is how I'm going to do it. So I will simply stand at this arc here. And this point, I mark an arc there. And then stand at this point of intersection. Now I'm bisecting this angle. I'm bisecting 60 degrees. I cut that arc. So now if I draw a straight line passing through that point, that will be 30 degrees. So draw a line. So now that is 30 degrees. So this angle here, this angle is 30 degrees. Then from there, you have to ensure that PR is 8 centimeters. So from P, start at P and take a measurement of 8 centimeters. So take a measurement of 8 centimeters. So from your ruler, take a measurement of 8 centimeters like that. That is 8 centimeters. So take 8 centimeters, that is 8 centimeters. Then stand at P and mark an arc there. So this is where we shall have R, that point. And then from there, I think our triangle will be complete, since the only thing that you need to do is join R and Q. So join R and Q. So join R and Q. Like that. And now you have the triangle. This is 8 centimeters. So you have the triangle PQR, whereby angle QPR is 30 degrees and line PQ is equals to 8 centimeters. So that is the first part. Part B, on the same diagram, construct triangle PQ, this is PRS, such that point S and Q are on opposite sides of PR, and given that PS is equals to SR and QS is equals to 8 centimeters. Now you have to construct another triangle PRS, and point S and Q should be opposite sides of PR. You can see where PR is. So those points should be on the opposite side. And whatever is going to help us here is this PS is equals to SR. PS is equals to SR. PS is equals to SR. Now, using that, it is possible, because that will form an isosceles triangle, PSR, and therefore, we need first to bisect PR. So if we bisect PR, that would help us to get PR or PS and RS being equal. So we bisect PR, this is how we bisect it, not to bisect a line. So standing there at P, just open this on more than half of that line PR, and then mark an arc there, and another one here. Then with the same radius, we're changing it. Stand at that point, cut that arc, and then cut that arc. There. Then you can join. This will be perpendicular bisector of PR. Like that. So this one would assist us because we want to get S. Point S will be somewhere on this line because we want to ensure that PS is equals to SR. So now the information that is going to help us here, you have QS. So from Q to S, S will be somewhere on this line, be somewhere on that line. So QS will be 8 centimeters. So this is what you do. You're standing at Q, take a measurement of 8 centimeters. Take a measurement of 8 centimeters. So let me take 8 centimeters. So that is 8 centimeters. So with 8 centimeters, stand at Q. You stand at Q and mark an arc. Mark a point there on that line, perpendicular line. So this point, this particular point here, this will now be S. Now you notice, now if you join this point S to P, if you join S to P, and S to R, you'll notice that these are equal now. Those lines are equal. According to what you're given here, PS is equals to SR. So PS is equals to SR. So what has helped us there is this perpendicular, by constructing the perpendicular bisector of PR. So that is what has helped us to identify S. And then you have QS being 8. So if we join this one, we can join it. We can join Q to S. So that is Q to S, that is 8 centimeters. Now that is all on that. So we have triangle PRS. It is there. That is an isosceles triangle. Now part C, a point T is on a line passing through R and parallel to QS. If angle QTS is equals to 90 degrees, locate two possible positions of T and label them T1 and T2. Measure the length of T1, T2. So you have a point T on a line passing through R, and it is parallel to QS. So you can see where we have QS. So QS is here, QS is there. So we need to construct a parallel line to QS passing through R. That line should be somewhere here, but it should pass through R. So how do we construct a parallel line from a given point? So you have this point. So we construct a line through this point that is parallel to QS. So you know that the distance between any two parallel lines should be constant. So the first thing you can do is by getting the perpendicular distance, the distance between this point R, and you can see this point on this line. I can name this one as point M. We name this one as M. So MR, we need to get that. But now it should be perpendicular distance. There are several ways through which you can construct a parallel line passing through R and is parallel to QS. You can use a set square and a ruler. I will use a pair of compasses only by just getting the distance. You know very well that if you have two lines that are parallel to another, this perpendicular distance between them, this distance should be constant. So I want to get this distance between. And to get that perpendicular distance, I'll simply stand here. I drop a perpendicular to QS. I can mark, you simply mark, can simply mark an arc there. Let me make sure that I'm gonna mark it there. So I can extend this line. Let me extend this line. Can extend that line there. Extend this on a line properly. Like that, yeah. So standing at this point, mark an arc here, and then mark another arc there. Then standing at this point here, in this arc, I can mark an arc there. Then on this arc here, cut that arc. So I'm dropping perpendicular from R. So I want to get that distance. So let me join. Let me join this point here. So now my interest is this distance, this distance from this point to this point. So this perpendicular distance, that is what I want. So now I need to get this distance. So from R to that point, so you can see that distance. Let me display this on properly so that you can see it. So you can see this distance, this distance that is here. That distance, you know, the parallel line should pass through R. So that distance should be constant. So what I'm going to do, I'll simply stand at Q with that distance, this distance taken here. Stand at Q, and then from Q I can construct an arc there, and then I can stand at S, and then I mark another arc here. So that line that I'm going to draw passing through the top of this, you draw a tangent, a straight line passing through the top of those arcs. That would be the tangent. You know how to draw a tangent, So that line, so can draw it in red so that you can see it. So the line that I've drawn, so that is the line, and you can see that it is passing on top of these arcs, and I have taken this distance. You can see I have taken this distance here. So from this point, that distance should be constant. That distance should be constant. That is what I've used. So using that distance, perpendicular distance, I've stood here, made that arc, then stood at S, made that arc, and then joined. So this line is parallel to QS, passing through R. Then after that, there's something else that you need to do. There's an angle that you're supposed to construct. So angle QTS should be 90. So QTS, remember that T lies anywhere along this line that I've drawn here passing through R. So T lies along anywhere on top of this line. It can lie anywhere. And you need to construct T such that QTS, you can see where S is. So QTS should be 90 degrees. For this question, you need to remember that if you have, there's a property, angle property that you need to remember, that you have, that is the diameter. So if this is the diameter, and then you draw any angle subtended by the diameter, the circumference should be 90 degrees. That is the property that you're going to use there. That is a property. So if this is the diameter subtends an angle of 90 degrees at the circumference. So that means that using this line QS, we should actually take QS as the diameter, so that when we draw a circle whose diameter is QS, and you draw a circle, that any point that will be touched by that circle, the first one will be T1, the other one will be T2. So we need to construct a circle whose diameter is QS. How do we do that? Already we have the length of QS is 8 centimeters. So half of that line will be 4 centimeters. To be 4 centimeters. So we need to get 4 centimeters to get in order to use the radius to construct that. So let me get 4 centimeters. So 4 centimeters. So from here, this is Q. So 4 centimeters is there. So using this one as a center, using that one as a center, I construct a circle, and that circle will definitely pass through, will cut 2 points. So that is a circle. So if you construct that circle, you can see the circle is passing through. It is cutting this line where T lies. T lies anywhere along this line here. So the first one will be, this point will be T1, and then this point will be T2. So this is T2, this one is T1. Then this is the diameter. So any angle subtended, if for example, if I draw a straight line here, like that, that point, then from T2, so look at this, Q T2S, that will be 90 degrees. That will be 90 degrees. And also QT, these are the point here. If you draw straight line there, and it's passing through this point here. So again, this angle here should be 90. The property that you're using is this angle subtended by the diameter of the circumference should be 90 degrees. So T can be here, T can be here. So the question is get the distance T1, T2. Simply measure that. You can use a ruler to measure that. So let me measure that. And this will be mine is 5. Mine is exactly 5. Mine is 5 centimeters. Mine is 5 centimeters. So this is 5 centimeters. May you confirm again? Now it is 5 centimeters. There might be a slight difference from the answer given, since I've had to transfer this line PQ from the book. I don't know whether that was the right measurement from the question paper. Maybe that is why you may realize you may not get exactly the same answer, slight different answer from what is given there. Is that how we're supposed to solve that question?
Simple!